Hello everyone, this is Rashida. Welcome to my channel. In my last two videos, we worked on basic regression and classification models in TensorFlow, Keras, and Python. In this video, we will take it a little bit further, a little more advanced, so that we can improve those basic models a little bit using some callback functions. So what is callback functions? Callback functions can be used during model training to prevent overfitting, to visualize training progress, to debug the code, to save checkpoints, to generate logs, to create TensorFlow, and more. In this video, we will show you how to use these two callbacks, early stopping and live loss plotting. You can set up early stopping so that when your model is not improving anymore, it stops training automatically no matter how many epochs you set it up for. Early stopping can help prevent overfitting and save a lot of time and computing power for you. And LiveLossPlot is also another interesting callback function. It will keep plotting the loss and evaluation metric while training. Okay, let's move to the code. As you can see, I'm going to use a Google Colab notebook for this project. And to begin with, we need to install LiveLossPlot because we are going to use it. Okay, here is a necessary import, the NumPy, Pandas, Matplotlib, Keras, and then as we are going to use early stopping today, so from keras.callbacks, import early stopping, and then label binarizer. We will see how to use label binarizer. It might be new for you, or if you already know it, then that's great. Then train test split. From LiveLossPlot that we just installed, import plot losses Keras, and then import TensorFlow as TF. Let's read the dataset into a data frame. So today we are going to use this fashion MNIST dataset, and I have the link of the dataset in the description box below. Please feel free to download the dataset. It has some fashion items, total of 10, and we have the label. Label ranges from 0 to 9. And here we have the shape, total of 60,000 data, and we have total of 785 columns. One of them is labeled, so total feature will be 784. So first, I want to separate the labels. So y df.label, that just this column here. And then let's see the unique labels. We have actually 0 to 9, as I already mentioned. These are the labels. And if we just drop this label from this df, we get our training features. That's what I did. X equals to df.drop columns label. Now you see x.head, we have only the pixel values. Here in this line of code, I'm just taking one of the rows from this x. I am taking the 10th row and then reshaping it into 28 by 28 array and then using plt.imshow, so it's a picture of a shirt. You can try some other ones as well. Instead of 10, maybe 18. You see, it's some kind of shirt again. Now maybe 67. It's a shoe. So we have total of 10 different kinds of fashion item like that. So if there is any null value, I'm just going to fill them up with zeros. There are other ways of filling up the null values. I have a separate video on that. Please feel free to check if you want to try them. But for this one, we have only maybe one or two null values I checked. Just filling the zero will work. And just to normalize the data, as these are the pixel values, they ranges from 0 to 255. So if I just divide by 255, it will normalize and the data will come into the range from 0 to 1. Finally, I'm just going to use this train test split method to divide the data into training and testing data. So x train, x test, y train, y test, train test split. I have to pass this x and y and then test size 0.2. That means 20% of the data is going to be for testing purpose. And then random state 24, you can use any other integer of your choice. So one more data preparation I will show you today, that is we are going to binarize our labels. So we have these labels, we are going to binarize it. How that works, let me show you. So if you have 1, 2, 3, 4, After using label binarizer, it becomes like this. When you will take 1, the first one is going to be 1, and other 3, 2, 3, and 4, all these 3 places is going to be 0. And when it's 2, the 1 is going to be 0, 2 is going to be 1, because this is positive, and 3, 4, they are going to be 0. And when it's 3, only the 3 is going to be 1, and the other ones 0. And for 4, 4 is going to be 1, and other ones are 0. So that's how you binarize the labels. So this is what I am going to do. Let's start doing it. LB label binarizer, then y train lb dot fit transform. So we will do the y train fit transform. Okay, now for y test we have to do only the transform, lb dot transform. Now let's see how y train looks like now. So you can see the binarization is done. Let's define our loss function. So it's going to be a categorical cross entropy loss function. Now let's define the models. So model tf dot keras dot models dot sequential model dot add. Let's add a dense layer. Layer dot keras dot layers dot dense 128 activation function ALU. Remember, we learned different kinds of activation functions. This activation function comes from a ReLU family, and if you want to know a little detail about it, I have a detailed video on activation functions. I have the link in the description box below. Please feel free to check. Model.add. I'll just add another of this dense layer. This time, let's add 64 neurons, and then let's just copy it. I will make it our last layer. So for last layer, the neurons is going to be 10 because we have 10 labels. And activation function, softmax. So the model development is done. Now compile the model. Model.compile optimizer. I will use Atom. Atom is one of the most popular optimization function. Loss, the loss function that we just defined. And then matrix is going to be accuracy. Now the exciting part. Let's define early stopping. Monitor loss. Okay? Early stopping. Let's pass the parameters to it. Monitor val loss. So this callback function is going to monitor the validation loss. Mean delta, I will put 0.02. This is the minimum amount of improvement we expect in each epoch. Next, patience. Patience, I'll put 5. If in consecutive 5 epochs the model doesn't improve any validation loss, in that case, it's going to stop training. Finally, restore best weights. You can see it's giving you the suggestions. Restore best weights. Oh, these are all equal sign. I'll put true. That means the model will get the weights of the epoch that has the best value for the validation loss. Okay, if we would put false, then it will get the weights of the last epoch only. Okay, the early stopping is defined. Now, define another callbacks, plot, losses, Keras. It's time to train the model. Model.fit, first X train, Y train, epochs. I'll put 1000 epochs. Let's see what happens. Validation data, X test, Y test, callbacks. First one is this callback. Let's give it a different name. Instead of callbacks, give it CB. Okay, that'll be much easier to understand. So CB and monitor loss. Now let's run and see the magic. So as you can see here, it will start plotting the losses and accuracies. Do you see that? As it trains, after each epoch, it's updating. You can see the epoch 8. Well, the training is done. The final accuracy we got 90% and for validation 87%. Not bad, right? And you can see we put 1,000 epochs, right? But it stopped after 7 epochs. Because after 7 epochs, the validation loss was not improving anymore. So, no matter how many epochs you put here, 1,000, 5,000, 10,000, it doesn't matter. As soon as your model stops training or your model stops improving, it will stop training. So, it prevents overfitting, it saves you time, it saves you computation power. Please try these techniques in your own model and share with us if you find any interesting results. I hope you like this video and please like, comment, share, and subscribe. Thank you so much for watching.